So on this page, we have two more in that perfect sum and difference of perfect cubes section, E and F. So we're going to do those first. Now on both of these, for example, on E, 5 and 40 are not perfect cubes. But I do notice, like I always should be looking for, that there is a GCF that I can take out first. So I'm going to take out a 5. I know this is going to be a little complex, so I'm going to use those brackets that we've used in a couple other lessons. And then we're going to look to factor the 8x cubed plus 8. So at some point, you can kind of throw this away, but I even think for a lot of people, just through the whole unit, since it's new, this might be easier. So this is difference of perfect cubes, or sorry, sum of perfect cubes. My A value is x, and my B value is 2. If you don't get that, you need to go back and rewatch the page 15 video. So from here, my formula for the sum of perfect cubes is A plus B, so that's x plus 2. A squared is x squared, minus bx, so minus 2x, plus b squared is plus 4. Okay? So this is just me factoring what was in brackets. You can throw out the brackets, though, after you write that. Looking at the next one, also not perfect cubes, but I have a GCF of 2, so I'm going to take out a 2, bracket it off, and we have 8x cubed minus 27. Now I do have perfect cubes. My A value is 2x, and my B value is 3. This is difference, so I'm going to use that other formula, similar but slightly different, right? So here I have A minus B, because it has to match the sign for the first binomial, 2x minus 3, and then A squared would be 4x squared, plus BX would be 6x, I'm sorry, AB would be 6x, and then B squared at the end would just be 9. Okay, so as I said, you can drop those where the blue brackets are, but that kind of helps you keep it separated from the GCF. So moving down to exercise 3, this is what your quiz, the majority of your quiz is going to look like. We're going to have a bunch of different factoring problems, and you have to recognize which method to use. Now, the biggest thing you need to remember is whenever you're factoring for anything, you are always looking for a GCF first. That sometimes you need to do that to make the rest of the factoring possible, but if you can find one, and there is one, it will always make the factoring that comes after simpler. So looking at the first one, I have A is greater than 1 with a trinomial, but I can take out that 4 and make this a much easier problem. So I take out the 4, and I'm left with that trinomial. So I'm just trying to find numbers that add up to 3 and multiply to negative 10. So those numbers are positive 5 and negative 2. I check all my factors, 4, x plus 5, x minus 2. Nothing else I can do with that to factor it further. The next one, I have, kind of looks like I might be heading towards difference of perfect squares, but 6 and 24 aren't perfect squares. But if I take out a 6, I have x squared minus 4. So that does factor further. That's difference of perfect squares, a plus b, a minus b, so x plus 2, x minus 2. Everything's factored. The next one, I have a is greater than 1. I do have a GCF, so I'm going to take out that 5. That doesn't completely remove the a so that it equals 1. We still have a 2 there, but it does significantly simplify the problem. So this is going to be plus 11x minus 21 for this one. So looking at this one, we still have a is greater than 1. So what I need to do is bring these two numbers together, right? So this is negative 42, and we want it to add up to 11 and multiply to negative 42. I'm going to bracket it off, right, because I want that 5 to stay on the outside, and I know this process is a little complicated. So numbers that works for, remember, rainbow, and then we split the middle. Numbers that works for are 14x and negative 3. So 14 and negative 3 will have 14x minus 3x. Now that is not factors of 42 that I think are super commonly known, like 6 and 7 most people know. So you might have had to do negative 42 divided by x on a calculator and look at a table to figure that out. Or, you know, guess and check and try numbers. So this is going to be plus 14x minus 3x minus 21. and then I'm ready for my grouping. It's a 21 right there. Let me just fix that. That's a 1. It's hiding. Okay, so we have 2x times x plus 7, negative 3 times x plus 7. So as my final answer, I have the 5. I take out the x plus 7, and I have 2x minus 3. So let's look at the next one, but we'll move down the page first. So here, once again, GCF. And a lot of times, I mean, on your quiz, not everything's going to have a GCF, but enough that you want to be confident that you understand that that's the first thing to look for. So a GCF here is 7, and that gives me x cubed plus 8y cubed. So I recognize that that's the sum of perfect cubes. Bracket that off. So I have the 7 outside. I'm going to label my a and b values. So my a value is x, and my b value is 2y for that second term. So then I start to factor it, and I have a plus b, so x plus 2y. A squared is x squared minus ab, so minus 2xy. Okay, and then we have plus b squared, so plus 4y squared. So as I said, can drop those brackets, but that is your final answer. So I am going to need to erase this one. So if you're watching through, hopefully you can just go back and get it. But I'm going to erase this side. And I probably shouldn't have put 3 problems in the same row with this type of factoring, but that's okay. Okay, next one. GCF is 2, so I'm going to take out a 2. And I have 6x squared minus 7x minus 3. Sorry. Bracket. So here we have a is greater than 1. So this is very similar to letter C. So I want numbers that add up to negative 7 and multiply to negative 18. So those numbers are going to be negative 9 and positive 2. So here I just split the middle to negative 9x plus 2x. Now we're going to group. 2's on the outside. And we take out a 3x and have 2x minus 3. We're just going to take out a 1 and have 2x minus 3. So then we're ready to finish our factoring. We have 2, common binomials 2x minus 3, and then we have 3x plus 1. So our next one is actually, grouping I think is easier when you get to start with grouping and you don't have to make the 4 terms. So this is 4 terms, so that's always grouping for factoring. GCF is A, so I have A plus 3B. GCF is 2, so I also have A plus 3B. Now common binomial is A plus 3B, leaving me with A plus 2. So there was no GCF on that one. I can look for one. There wasn't one to start out with. I just went straight to grouping. Letter G, I don't see any GCFs, right? So I'm just going to have to go straight to 36. And I have 6x squared. Multiples of 36, or factors of 36, sorry. Factors of 36 that add up to negative 13 are negative 4 and negative 9. And then we group. And then we take out the 3x minus 2 and leave the 2x minus 3. So from here, my next one looks a little crazy. I do see a GCF, so let's start there and see if it gets a little easier. So my GCF is 3x. That leaves me with 25x to the 4th y squared minus 1. Now, once again, still looks a little crazy, but if I check that, that's a perfect square, right? That's a perfect square, so we can do difference of perfect squares. So in parentheses, I have 5x squared y plus 1 and 5x squared y minus 1. So that's just your a plus b, a minus b. Usually with difference of perfect squares, I could write a equals and b equals and then plug them into that formula, but usually we're okay without doing that. But it's the same idea where we have this formula and we're finding the a and the b values based on the expression. So my next one, I see a GCF of x. Here, I went right to those parentheses because I see that the a value is 1 in front of x squared, right? So I can put my x's in, and factors of 63 that add up to 2 are positive 9 and negative 7. So that's a nice idea of what your quiz will be like with all those different problems together. There are some more on the next page, so I'm going to go over those as well. Hopefully you did most of them on your own, but this is a great way to come back if you couldn't figure out one and just watch a process.